Let us see the construction, working and applications of zinc-air battery. Zinc-air battery is a primary battery. Okay. Primary battery means what? Primary battery is a non-rechargeable battery. This zinc-air battery can be considered as a reserve battery. Okay. Let us see the construction of zinc-air battery. It is made up of four main components: anode, cathode, separator, and electrolyte. Here, anode is zinc metal. Zinc metal electrode acts as anode. Zinc metal acts as anode. Okay. And porous carbon electrode. Porous carbon electrode acts as cathode. This is porous carbon electrode. Porous carbon electrode acts as cathode. So anode is denoted by minus, cathode is denoted by plus. And these two electrodes are connected through an external circuit. Okay. And here electrons will move from anode to cathode. Right. And now inside the battery, these two electrodes are separated by a porous membrane or polymer membrane called separator. And this is separator. Okay. In this battery, aqueous potassium hydroxide is used as electrolyte. Aqueous potassium hydroxide is used as electrolyte. Aqueous means what? Containing water. Potassium hydroxide dissolved in water. Okay. And this is the construction of zinc-air battery. And let us see the working mechanism. Imagine this battery is sealed. Okay. In the emergency situation, when the seal is opened, atmospheric oxygen enters through this porous carbon and reaches this aqueous potassium hydroxide. Let us see the reaction at cathode. See, oxygen enters through this porous carbon and reaches electrolyte, right? This aqueous KOH means what? It contains some amount of water. So, this oxygen reacts with water present in the electrolyte by taking electrons from the external circuit and gives OH minus ions. It is a reduction reaction. It is a reduction reaction. See, these OH minus ions moves towards anode. These OH minus ions moves towards anode through this separator. Let us see the reaction at anode. Anode is what? Zinc electrode. So here zinc takes these OH minus ions and undergoes oxidation and gives tetrahydroxyzincate 2 complex ion and 2 electrons. Now, this tetrahydroxyzincate 2 ion dissociates and gives zinc oxide, OH minus ions, and water. Okay. Here you can observe that zinc loses 2 electrons, right? And that is why it is an oxidation reaction. Let us see the overall reaction. See, here you can write like this: overall reaction Zn plus half O2 gives rise to ZnO, zinc oxide. This is the overall reaction. Or you can write 2 zinc plus O2 gives rise to 2 ZnO. You can write like this also. Okay. This is the working principle of this zinc-air battery or mechanism of zinc-air battery. Let us see the advantages of zinc-air batteries. They have high energy density, so they give power for a long time. And it is more abundant and cheap, so the battery cost is low. And they have long shelf life because they start working only when air enters the cell, right? And they have low self discharge rate, so they do not lose charge quickly during storage. And they are environment friendly because they do not contain any harmful heavy metals. And mainly we use an aqueous potassium hydroxide as electrolyte, so that is relatively safe. And next, applications of zinc-air batteries. They are used in hearing aids, watches, calculators, and they are used in smoke detectors and remote sensors and military communication devices like radios, and used as backup power in telecommunication systems, and also used in railway signaling and safety lamps, etc.